I know way too much about torque and force that I didn't know last year. What's centripetal? I swear it feels like a lifetime effects, but I'm only 13 and I just can't remember it all. What is a new end? What am I doing? Oh yeah, that's right, I'm doing science. It's about asking, it's more than facts, man, it's action. And guess what I'ma be when I'm old?
Breaking news. This is Gilbert Grace here. The case of split personality disorder has produced disastrous effects on the scientists with dual uncontrolled personalities.
Well, I remember nothing about such thing. I was born normal without any disorder on October 7th, 1885, in Copenhagen, Denmark, to my mother, Ellen Adler, who was part of a successful Jewish banking clan, and Father Christian Bohr, a celebrated physiology academic. I attended Copenhagen University and then Cambridge, England to follow scientist J.J. Thomson. I married Margaret Norland, and we had 6 super cute children. With Adolf Hitler's rise in power, I gave refuge to German Jewish physicists in my institute in Copenhagen. This led many people to travel to US. Once Denmark became occupied by Nazi forces, I myself escaped to Sweden, and I took my son to the US with me. I worked with the Manhattan Project in Los Alamos, New Mexico, where the first atom bomb was being created. But I had concerns about how this bomb could be used. I was scared that bombs could be used to kill people. I didn't want to kill people. We called for international arms control and active communication about the weapon between nations. Winston Churchill and Franklin D. Roosevelt didn't like this idea, of course. Made me sad.
Now back to Gilbert, who will tell us more about the beginnings of Bohr's other life as Gustav Kirchhoff.
Is Kirchhoff an identity that just began, or do you have a childhood too?
Well, since you ask, I was born in 1824, Prussia, in a nice little city called Königsberg. And as a kid, I loved to experiment with physics and with technology and all these different particles. Well, I was different from my dad's line of work, since he was a lawyer and he studied law. What a nerd. While learning at the University of Königsberg, I happened to marry a very beautiful woman, which was my mathematician's professor's daughter. It was very awkward. I would later establish the theory of spectrum analysis, a technique for chemical analysis by analyzing the light emitted by heated material, which I then applied to determine the composition of the sun itself. Pretty cool, eh? In 1945, I would first announce a series of laws to determine current, resistance, and voltages in an electrical system called Kirchhoff's laws. Yes, I named it after myself. My laws allowed the inherent calculation of currents, voltages, and resistance of electrical networks. These laws would extend the theory of German physicist George Simon Ohm. I then generalized the equations describing current flow to the case of electrical conductors in the three-dimensional plane. My set of laws would then be used vastly throughout all colleges and electrical engineering courses. I later left my hometown university, Königsberg, to go to the University of Heidelberg to study the laws of thermal radiation. While I was there, my newly created laws of electrical calculations were being taught to the students. I would later discover the chemicals cesium and rubidium with my friend Bunsen.
Whose childhood is real? To whom belongs the real identity? After further information, it's up to the audience to decide the truth of this oddity. Dr. Bohr, how have you contributed to science?
Well, I'd like to clear up one thing. I do not remember making Kirchhoff's laws. I promise. I didn't do it. What I did do was combine Rutherford's description of the nucleus and Planck's theory about quanta, and I could explain what happens inside an atom. I also developed a picture of atomic structure. Back when I was handsome, this work earned me my very own Nobel Prize in 1922. My atomic model shows the atom as a small, positively charged nucleus surrounded by orbiting electrons. I also was the first to discover that electrons travel in separate orbits around the nucleus and that the number of electrons in the outer orbit determines the properties of an element. In addition to developing the concept of complementarity, which resolved key issues of quantum mechanics, I also helped open the gateway to nuclear fission when the splitting up of uranium was discovered in 1939. And borium, BH number 107 on the periodic table of the elements, is named after me. I also have around 100 publications, especially on theoretical physics, so check them out.
Hello, Gilbert Grace without glasses here. And, Kirchhoff, I have another question for you. Have you really contributed, or are you just plain crazy?
Both, Gilbert. In 1862, I received the Rumford Medal for my researches on fixed lines of the solar spectrum and on the inversion of the bright lines in the spectra of artificial light.
I contributed greatly to the field of spectroscopy by forming 3 laws that describe the spectral composition of light emitted by incandescent objects, building substantially on the discoveries of Alter and Engstrom. I also contributed to optics and solved Maxwell's equations to provide a solid foundation for Huygens' principle, and correct it in the process, of course. I also conversed with Bunsen to discover the elements cesium and rubidium. Because of me, electrical engineering in every prestigious college advanced further.
Ever seen one of those bad boys? Yeah, they wouldn't be around without me. That's because I came up with the concept of quantum leaps. Quantum leaps basically means when atoms emit energy. In that microwave in there, atoms emit energy and that's how your food gets heated. Heating technology wouldn't be around without me.
Time to learn about Kirchhoff's current law. This fundamental law results from the conservation of charge. It applies to a junction or node in a circuit, a point in the circuit where charge has several possible paths to travel. In this figure, we see that 1A is the only current flowing into the node. However, there's 3 paths for the current to leave the node, and these currents are represented by B, C, and D. Once charge has entered into the node, it has no place to go except to leave. This is known as the conservation of charge. The total charge flowing into a node must be the same as the total charge flowing out of the node. Therefore, if you bring everybody to the left side, you get minus equals 0. Therefore, the sum of all the currents is 0. This can be generalized as follows: summation equals 0. And that is Kirchhoff's current law, basics. Kirchhoff's voltage law, the second one, basically states that the total voltage around a closed loop must be 0. So, in this figure, loop 1 has to amount to 0, and the same goes with loop 2. Also, the outer part of the circuit, which is also A, B, C, D, this path also has to amount to 0. Therefore, you have
In this video, we're going to talk about Schrodinger's cat, which is a famous experiment, thought experiment, I should say, brought up by Schrodinger around the year 1935 in the infancy of quantum mechanics. And essentially, it goes like this. We start with a box, which is sealed from the outside universe, a totally opaque box out of which we can't get any information until we open it. Inside the box is a cat, and with the cat is a vial of poison, which does the cat no harm unless the vial is broken open by a device, which will only break the vial of poison if a particular atomic particle within it decays. A little radioactive particle, if it breaks apart, that will kill the cat. Now, Schrödinger meant this thought experiment to be a critique of the Copenhagen interpretation of quantum mechanics, and it has subsequently become actually a very meaningful and often used example of how superposition doesn't actually equate with what we consider common sense. Now, superposition is an interesting concept. It is a fundamental principle of quantum mechanics that tells us that the atomic particle exists partly in all of its particular theoretical possible states, meaning that it has both decayed and not decayed simultaneously. It's like a cloud of probability, right? It's both the one thing and the other at the same time. Only once the atomic particle is observed, or the effects of its decay are observed, or the effects of its non-decay are observed, does the actual state become solidified and particular to the state, or become the particular state of that atomic particle. So until we open the box and observe what has happened, both events are in superposition and are coexisting within the box. So the cat is both alive and dead until we open the box, at which point the state of superposition collapses and we see either a live cat or a dead cat. Now, the Schrödinger's cat thought experiment is often referred to as a paradox being a state of two contradictory things being simultaneously true. But another interpretation of it is that it is an example of the multi-universe theorem, which basically states that for every event, quantum or otherwise, that could go one way or the other, a new universe is created, or I should say two new universes are created, one for each possible outcome. All right? So in the morning, if you're waffling between the idea of having jam on your toast or honey on your toast, a universe will be created for each possibility. You will both have honey and jam on your toast. It's just that the you that follows the path of jam never sees and cannot contact or communicate with the you that decides to have honey on their toast, right? So basically, until the box is opened, those two universes, the live cat and the dead cat, exist simultaneously within it. Or something like that, right? It's a bit of a mind bender. But these are the basics of Schrodinger's cat. I hope you enjoyed this video, and if you did, please subscribe to my YouTube channel. Take care.
We asked some civilians on this serious case. Let's go. What do you think about the mad scientist?
I would later establish the spectrum analysis, chemical technique that would analyze. My mustache.
Copenhagen, Denmark. To my mother, Ellen Adler, who was part of. What am I doing? Ready?
Wait, where are we starting?
I attended Copenhagen University National Arms Control, and then active.